Assalamualaikum and good morning everyone. Today we will continue our lesson on subtopic 4.4 gas laws. First question, state the physical quantities that are constant in Boyle's law, Charles' law and Gay-Lussac's law.
First, we'll look at the relationship between pressure and volume. We'll hold moles and temperature constant by using a sealed container and a consistent temperature. When we decrease the volume, the pressure increases. This is an inverse relationship, which means the variables will be on the same side of the equation and the constant will be opposite. Here's the equation for pressure and volume. Pressure times volume equals some constant. Now, to see where Boyle's law is coming from, we need to look at the starting pressure and volumes, and finishing pressure and volumes. Mathematically, we can use substitution to put these two equations together because they both equal the same value, K. In magic, we have Boyle's law. Have you ever put a balloon in a freezer? Pull it out after a few hours and you'll find a shrunken balloon. As it warms up, it will come back to full size. As temperature goes down, volume goes down. This is a direct relationship. This is essentially the same as Gay-Lussac's law, except we're using volume instead of pressure. If you rearrange the equation and then substitute it, you get Charles's law. V1 over T1 equals V2 over T2. The next law looks at pressure and temperature, keeping moles and volume constant, and sometimes it's called Gay-Lussac's law. We know that when temperature increases, pressure also increases. This is a direct relationship, which means the variables will be on opposite sides of the equation. Pressure equals temperature times the constant. Just rearrange a little, and now when we compare the before and after, we use substitution again to get Gay-Lussac's law.
Based on the video clip just now, we can see that the constant quantity for Boyle's law is temperature, for Charles' law is pressure, and for the Gay-Lussac's law is volume. Now let's continue to question number 2. Right? A syringe contains 50 centimeter cubic of air at a pressure of 110 kilopascal. So this is the initial volume and pressure. And then the end of syringe is closed and its piston slowly pushed until the volume of air becomes 20 centimeter cubic. Now find the pressure of the compressed air. So the information given is the volume and pressure, so we need to apply Boyle's law. Right? P1 V1 equal to P2 V2, and then we just substitute the value and voila, that's the answer, 275 kilopascal. Now, let's continue to question 3. An air bubble trapped under a leaf in a lake has a volume of 1.6 centimeter cubic at a temperature of 38 degrees Celsius. Now, look at the temperature given. It is in degrees Celsius. So remember, in gas laws, you need to change the quantity, the SI unit for degrees Celsius to absolute temperature, which is in Kelvin. Then calculate the volume of the bubble if the temperature of the water in the lake drops to 26 degrees Celsius. Again, we have to change to absolute temperature. Alright, when we want to apply the gas law, the temperature must be in absolute temperature, which is in Kelvin. So, alright, V1 T1 equal to V2 over T2. So, you need to substitute the quantity of volume and the value of temperature, which is initially in degrees Celsius, okay, plus 273 Kelvin for T1 and also for T2. And then you just calculate. There is the answer, V2 equal to 1.54 centimeter cubic. Now, if you look at the question, okay, the air bubble trap under the leaf has a volume of 1.6 when the temperature is 38 degrees Celsius. Now, when the temperature drop, okay, when the temperature drop, the volume is drop 2, isn't it? Because the temperature is directly proportional to volume. Question 4. Pressure in a gas cylinder is 175 kilopascal at a temperature of 27 degrees Celsius. Heat from a nearby furnace causes the gas pressure to increase to 300 kilopascal. What is the temperature of the gas inside the cylinder? Now, look at the information provided in the question. Alright? The variable that is given is pressure and temperature, and then the temperature is again in degree Celsius. We need to substitute to absolute temperature, which is in Kelvin. Alright, to solve this problem, we need to apply Gay-Lussac's law when P is directly proportional to T. It means that when temperature increases, the pressure will increase too. Alright, if you refer again to the question, alright, the final pressure of the gas had increased. So we expect that the temperature also will increase based on the Gay-Lussac's law. Okay, now write the equation P1 over T1 equal to P2 over T2, and then we just substitute the number. Alright, and don't forget to add 273 Kelvin to the temperature, which is in degrees Celsius. Alright, and then final temperature, okay, T2 equal to 514 Kelvin. The results obey the Gay-Lussac's law. Alright. That's all for now. Thank you very much. Till we meet again. Bye and Assalamualaikum.